Hello class and welcome to lesson 1.4 using a graphing calculator. Well, before we get to the graphing calculator part, let's just do warm-ups that should consolidate your learning from last lesson. So last lesson we learned all about y equals mx plus b and switching the forms and how to give the equation of the line. So let's take a look at two examples in number 1, which says to determine the equation of the line. For A, it says whose slope is -2, so we automatically know m equals -2. And the y-intercept is 6. Please remember that y-intercept represents the letter b, so b equals 6. And once you know those two pieces of information, you can then sub it in. Therefore, y equals -2x plus 6. And that's your equation. Now that's an easy one because the slope and the y-intercept are given. When we take a look at example B, we're trying to find the equation of the line joining 2 points, A and B. So think of them as endpoints, okay? And you want to try to find the equation. The problem with this is we don't know what m equals, and we don't know what b equals. So we're going to have to figure that out. Well, when we have two ordered pairs, folks, we can use the slope formula. That is y2 subtract y1 over x2 subtract x1 to figure that out. And if you remember, folks, that A is our first ordered pair, so we're going to label it x1, y1, and B is our second pair, so we're going to label that x2 and y2. Just remember that ordered pairs always have x first, then y after. Okay, so subbing this in, y2, ladies and gentlemen, is -4. Subtract y1, which is 4. All divided by x2, which is -2. Subtract x1, which is -2. Moving up here, just because I need some room here, we're going to simplify the numerator. So for slope, we got -8 divided by -4. Okay, simplify that out. Negative divided by negative is a positive, and 4 goes into 8 twice. So you're going to end up with slope equaling 2. So we got one piece of the puzzle, but we still don't have the b. And you might remember this as a harder step that we did. I'm going to write the equation y equals mx plus b, and I'm going to sub in the slope. So I'm going to go y equals 2x plus b. And that's a start, ladies and gentlemen, because that's the information we know already. And if we want to get b by itself, we've got to sub in values for the y and the x. So what I want you to do is pick an ordered pair, either A or B, and sub those in. The x value would be the x coordinate and the y value would be the y coordinate. Now I always try to keep math as simple as possible, so I'm going to substitute in the A point because there's positive values as opposed to negative. So when I sub that in, y will be the y part of the coordinate, so it's going to be 4 equals 2 times my x1, which is 2, plus b. Notice, ladies and gentlemen, that now all I have to do is rearrange for b, and I can solve it. So I've got 4 equals 4 plus b. Okay, to get b by itself, I take the 4 here and I move it over, change the sign, so it's going to be 4 subtract 4 equals b. So b is going to equal 4 subtract 4 is 0. So now that you have the two parts of the equation, you're going to go therefore y equals 2x plus 0. There's no point in me putting plus 0 down because it would be eliminated because it doesn't affect the equation. So our equation becomes y equals 2x. All right, example 2. For each of the following, create a table of values and then graph it to determine whether it is a function or not. Okay. Well, looking at A, ladies and gentlemen, this equation, we should hopefully recognize it as a linear equation because there's no exponents. But the confusing part here is it's not in the form of y equals. So we're going to do a couple steps to get it into y equals mx plus b. So the first term we want to get by itself is the 3y. Okay, and why is that? Because we're going to get into y equals. Just give me 1 second. I apologize, ladies and gentlemen. I need to reset this. And I know it's frustrating because I will not be able to be accurate on my graph either, so I will do this again. There, hopefully that's better. So let's try that again, guys, see if we're more accurate. Oh, now we are, good. So the 3y, that's the term with a y, we're going to leave it there. We're going to take the positive 2x, bring it over, change it to a negative. Okay, and leave the plus 6 where it is. So far we now have 3y instead of y equals mx plus b. We got 3y equals mx plus b. But to get y by itself, we need to divide it by 3. Whatever you do to one term, you have to do the same to the other. So our equation that's going to make us be able to substitute in is y equals negative 2/3 x plus 2. All right? That's what we're going to use to help us substitute in. Okay? Now remember, this is your input x, so that's your input. Okay, computer, you can work now. Oh, maybe it's not working. Let's see. See if that'll work now. There we go. So that's our input value, and then we're going to get an output. And that's why we needed to get y by itself, so that we get outputted. So if I take a look at my first data that I'm going to try to enter in, I'm going to enter in a negative 6 for x. So it's going to be y equals negative 2/3 times negative 6 plus 2. Okay, you can use your calculator with your fraction button, or just use your mental math here to simplify this. Okay, I'm just going to erase that. Apologize. I'm going to use same colors so that you see this clearly. So a negative 2 times a negative 6 is positive 12. 12 divided by 3 is 4. So 4 plus 3 is 6. So I'll just show you a little simplification there. So that became 4 plus 2. So y equals 6. So you put a 6 in there. Okay. Next one, substitute in negative 3. So y equals negative 2/3 times negative 3 plus 2. Okay. Couple simplifications here, guys. Negative times a negative make a positive, and the denominator 3 and the numerator 3 cancel. So you got 2 plus 2. So y equals 2 plus 2. So y equals 4. Okay. All right, so at a grade 10 level, folks, you can just do that work in the calculator or in the side margin. I don't need to see this, okay? But I was just showing you how you do your substitutions. For the third one, when you sub in y equals 0, the whole fraction part equals 0, so you're going to have 2 for an answer. When you sub in 3, you got to watch when you cancel that there's still going to be a negative there, so you end up with a final answer of 0. And subbing in 6, you're going to end up with negative 2, okay? We already suggested that it was linear because the equation doesn't have any exponents, but check out our first differences, folks. Each time there's the same pattern, rate of change, right? So we'll graph them in a minute, guys. We'll just we'll do B and get the table for B first, okay? What's different about B, folks, look at the equation. It has a squared on it, so that means it's going to be nonlinear, and this is a parabola, which is going to be something familiar when we get into the quadratics unit, okay? So there's a quadratic relation, so it's nonlinear, and we are going to we're going to then determine if it's a function or not, but we'll wait till we graph that. So first of all, let's enter in the values. So for the first one, just to make sure you know your substitutions, y equals negative 2, square that, and then subtract 3. So negative 2 squared is positive 4, subtract 3 is going to be 1. Try your next one, y equals negative 1 squared, subtract 3. So y equals 1, subtract 3, so y equals negative 2. Okay, sub in 0, 0 squared is 0, subtract 3 is negative 3. 1 squared is 1, subtract 4 is negative 2. And 2 squared subtract 3 is 1. Okay? So now once you've got, and notice, guys, that the rate of change is different. So that's why it's nonlinear. Okay? All right, so let's plot these. You could plot the first one, ladies and gentlemen, using ordered pairs, or I'm just going to quickly review the shortcut way. I noticed that B equals 2, so I'm going to start at 2 on my y-intercept, and I know that my slope, m, equals negative 2 over 3. So from that, I'm going to go down 2 over 3, down 2 over 3. Okay, and then I can draw a straight line right through. Okay, good. And remember, ladies and gentlemen, that you need to have arrows on both the front and the back. And as well, you need to label the equation y equals negative 2/3 x plus 2. Okay, Or you could put the original one in. You could also put in 2x plus 3y equals 6. I'm okay with that. Or you could have just plotted the ordered pairs, folks. You could have just plotted the ordered points and you'd be fine there. All right, next one, taking a look at our nonlinear relation. Okay, for this one, ladies and gentlemen, we haven't learned any shortcuts yet, but you will in this course learn how to draw this in a more efficient manner. So for now, we'll just plot the points. So -2 and 1, -1, -2, 0, -3, and 1, -2, and 2 and 1. Okay, so ladies and gentlemen, this is a curved line. It's a curved U shape called a parabola. Okay, and then we put the equation on y equals x squared minus 3. Now in warm-up it's asked to determine if it was a function or not. Okay, so to do that function, I'm going to take a bar and I'm going to move it from left to right. And for A, as I move left to right, it's only hitting my bar at one spot. So yes, it is a function because it passes the vertical line test. Okay. Okay, and you could also further say, therefore, linear function. All right. Take a look at the second example, ladies and gentlemen, as I take my bar across my parabola. Notice that at every case, it's just hitting the line once. So yes, this is yes, because it passes the VLT. And you could say this is a nonlinear function, or you could actually say, therefore, it's a quadratic function. We're going to learn a lot about that this year, and you'll be guaranteed you'll have questions like that on your final exam about quadratic functions. Okay, a couple things, quick things about your quadratic, folks, is you notice there's this turning point right here. This turning point is, hi Deetsy, how you doing? You want to do some math with me? Okay. Mr. Dietz is just cleaning up, folks, and he loves math, right? Yes, loves math. So this is the vertex, ladies and gentlemen. Okay, and that's either the lowest or the highest point. Okay, and we're going to call this a parabola. So just put the wording parabola down, just to give you an indication. So next time when I ask you for the vertex, it's the only point that doesn't have a matching symmetry point. So what I want to say is that if you think about a mirror image, folks, a parabola goes through the vertex, and every other point, for example, see these points that we plotted? They're mirror images in terms that they're equal distance from the axis of symmetry. Okay, so a parabola is very symmetrical. All right, that's the warm-ups, ladies and gentlemen. Now we're going to get to the graphing calculators. Now, if you're doing this at home, you don't actually have a graphing calculator because we use them in class. However, you can find any online graphing calculator or any app on your phone. You might even have one on your phone that will do the same thing. Okay, but if you're using a graphing calculator, or you can come and see me and borrow one, that would be fine. You just can't take them home. You could borrow them at lunch or whatever. Just make sure that you reset the calculator, and I'll go over that. I have a sheet on my sideboard of how to reset the calculators. Okay, and what we're going to do is to get you to write this out first, and then we'll do an investigation together. Okay, so put this kind of like in a box. So to graph data from a table, so that's giving you ordered pairs, we're going to enter the data. And I'm going to put some buttons in here so it'll be easier for you to do that. So to enter the data, you're going to go stat, which is a button right in the middle, and enter. I'll show you when we do this with the calculator in a minute. Okay, we got to set up the graph, which means we're going to turn the plots on. So to do that, you need to go second y equals, which is your stat plot. Okay, and then later we will set up the window, which is window button, and then we're going to graph the data, which is a button that says graph. Okay, we will use graphing calculators from time to time to help us in this course, but you won't have them on your final assessment. All right. So as a class, we will complete investigation 1 and parts 1 and 2 only for investigation 2. So what we need to do in our textbook is to look at page 32, and then I'll get the graphing calculators going here. All right. So, page 32. On page 32, guys, you'll notice that there's a table taking a look at cans, and it says cylindrical can packages of many different sizes are shown in the table below. The diameters and heights were measured, and the capacities were recorded from their labels. Okay, so that's the information we're going to input into the calculator. All right, so let me just minimize my lesson for a second. Okay, and I'm going to put on the graphing calculator app, which is right there. Okay, so just to take a second to pop up. Okay, so this is similar to the one you have in class. Mine's a silver one, yours is blue. Okay, so the first thing we want to do is to reset our calculator. So the first thing in reset is you're going to press a bunch of buttons. You're going to go second, plus sign, 722, and that's going to be default set. So that's just clearing any new programs that might have been there. The second one is to clear the list where the data has been in the past. So we're going to go second function, plus sign, 4, enter, and it says clear list done. Then we're going to go to y equals, which is your blue button right up here. Okay, double check that you don't have any equations. If you did, you'd press clear down arrow, clear down arrow. Okay, but you're fine where it is. Okay, and then what we're going to do is we are going to do something called mode float 2. Sometimes it asks you to be accurate to a certain number of decimal places. So right now I'm going to hit mode, and I'm going to go down to float and over to 2, which means I'm going to set the calculator to 2 decimal places. And I press enter. Now that we've reset everything, okay, if I hit enter, we should be good. Okay. So now reading the investigation number 1, comparing the heights and diameters, it says press stat and 1, or stat and enter. So I'm going to press stat, press stat and enter. And notice I've got the list there. Okay, it says if there are numbers there, they need to be cleared, but we've already done that. Then the next bullet on page 33 says move the cursor down below L1. So down below L1, okay, and it says to enter in the diameters. So I'm just going to read them off the list, folks. So I'm going to enter them in 5.2, 6.0, 6, oh, sorry, backspace. Sorry, guys. Clear, clear, clear. Okay, let's try that again. So I made an error, so I've got to go back up and hit clear or delete. Okay, and you can just write over top of it. So I'm just going to go 5.2, enter. Okay, and then I go 6, enter, and then 6.3, enter, and then 7.2, enter. Gotta do that 3 times. Okay, and then I've got 8.2. Oh, gotta go back up. I made an error. It happens. Okay, I'm having trouble, guys. Sorry, my graphing calculator is not lining up, so I'll see if I can get better at this. 8.2, enter. 8.2, enter. And then 8.4, enter. And 9.9, enter. So when you're done, ladies and gentlemen, see how if I move the cursor up where it says 9.9, right here. Ha, see, that's why my calculator's off. I'm going to try and go lower. There. That's saying in L1, so column 1, I have 12 data points, and the 12th data point is 9.9. You want to make sure that when you go to do the next step, which says move the cursor to the space below L2, that you enter in the heights. So you want to make sure you have the same number of data points when you're done. All right, so let's do that. So we're entering the heights, which is 8.2, 11, 7.3, 9.6, 10.5, 7.6, 7.9, 8.2. See, I missed that. I got to clear that. So let's go 8. Sorry, guys. Give me a second. My calculator's bugging me. There we go. 8.2. I'm close to being there. 8.2. Enter. 14. Enter. 11. Enter. And 11. Enter. Okay? So I've got my data in. So now I'm going to flip the page 33 onto 34. It says check to make sure the data is entered in correctly. So make sure that you don't have any errors. And I can spot one right away in my L2. So it should be 7.9. I've just got 0.9. So I'm going to go back over. I'm going to go up. Fix that. So I have 7.9. Okay. And I think the rest is fine. Okay, and then it says we need to, step 2, set up the graph. So to set up the graph, you press second, which is right here. So second, and then y equals. Okay, and then you have to turn the plot, you press enter. Okay, now currently it says the plots are turned off, so you want to be able to turn them on. So what I do is I move my cursor over to on and hit enter. And notice here, guys, beside X1, right here beside X list and Y list, that it's got to be L1, L2. What we're doing is taking a table of values and making L1 be the X values and L2 being the Y values. All right, so far that's good. Now we need to, after we've turned it on, now we need to just press graph to see what happens. All right, so I like to press graph, so press graph. And notice I've got some data there, but I don't have all of them. And that's because we haven't set the window up. So to set the window up, you press window, which is right here. Press window and change your data points. So it gives you a suggestion on the top of 35. But think about X min represents what we entered in on L1, which should be the diameters. Does it make sense to have negative values for your diameter? No. So we're going to let that be 0. Maximum, ladies and gentlemen, is around 10, so we're going to put down 12, just so that we see it. Okay, so 12. Okay, hit enter. The scale they suggest is 2, so they're going to go up by 2 centimeters each time. Enter. Y scale. So what we entered into the Y's was the height. Should we ever have a negative height for a KN? No, so that's going to be 0. And the Y maximum is around 14, so we'll make 15 so we can see it. And change your scale to 2. Okay, now that we've changed our window, let's press graph. And now we've got our data. Great. Okay, so taking a look there, ladies and gentlemen, now we have our data, which we've created a scatter plot. All right, great. Okay. Next step, ladies and gentlemen, is what we're going to take a look at is investigation 1 and parts 1 and 2 only of investigation 2. All right. So taking a look at the next one, ladies and gentlemen, I'm on top of page 36 now. I'm going to do the volume one. So bottom of 35, which is volume and capacities. So it says to take your go to the list editor, make sure that your L1 is the same. So go to Stat and enter. Okay, so we already have L1 and L2 and L3. So L1 contains the diameters. Okay, and L2 contains the heights. Okay, let me just double check here that we're on the right track. Okay, that looks good. Okay, and then it says Since the formula involves the radius and the diameters, move the cursor to the heading of L1. Okay. So I'm going to take my cursor. I'm going to move it up onto the heading of L1. Okay. And it says press second 1 divide 2. So what we're doing is we're taking the diameter and dividing it by 2. Why is that? Because when we're looking at doing volume, ladies and gentlemen, we need to have the radius, which is half the diameter. So we're going to go equals. Okay, so you're going to press second. Okay, so you're going to press second 1, which tells me we're taking a look at list 1, and we're going to divide it by 2. Okay, and press enter. Notice what's going to happen to your data points here. They all go in half. Okay, then it says move the cursor. Calculator will divide them all by 2. Okay, you are now ready to calculate the volumes of the cans. Okay, so now you have, up to now, you've used lists 1, 2, and 3. I don't remember where you used list 3. Let me back up quickly, guys. I don't think we have done list 3. So now what we're going to do is, I'm just going to pause for a sec to make sure I'm not going to run you into the wrong direction. So give me 1 sec here. Let me see if this is working. Okay, I guess we're on now because it's not dark. Okay, sorry guys. So I forgot that we need to go over and put in L3. I missed a bullet there, guys. If you go back to the page 36, number 2, I forgot to put in the capacities. So we're going to cursor over to L3, put in the capacities. So you got to go way back to page 32, put your capacities in. So it's going to be 156, enter, 160, enter, 340, enter, 300, enter, 385, enter, 398, enter, 284, enter, 341, enter, 398, enter, 725, enter, 540, enter. I missed a 0 there, so I got to go back up. Try that again. 5, 4. See, I did it again. There we go. 540. That's better. Enter. And last one, 796. Enter. Okay, we're all caught up now. Now I can go back to what I was trying to do before, which is number 4. It says, now you're ready to calculate the volumes. Up to now, you have used lists 1, 2, and 3. The list editor contains 3 more lists that you can access. Move the cursor to the heading of L4. So you go up, arrow up all the way to the top. Okay. Hit L3. When you get there, and then go over 1 to L4. Okay. And then we're going to enter in the equation there. So take a look, folks, at 4B in your textbook. So you're going to press second hat, which means expression. It's the exponent button. Second 1. Okay. And then we're going to press x squared. Second 2. Okay, so before I press enter, guys, we remember that it's pi r squared h. So pi was the number we got at the beginning. R is what we've made in L1. We've got to square it, pi r squared h, which is the formula for the volume of a cylinder. Okay, press enter and watch what happens. All the volumes will fit in there. Okay, so number 5, press second y equals. So this is to turn on the plots. Okay, so second y equals. Okay, stat menu, choose to plot. Plot 1, make sure L3 appears beside X list. So we got to go in here first, so press enter. And then we're going to change some things here. So between X list, we want to have L3. So in order to do that, ladies and gentlemen, you need to go second and 3. So second and 3, and you'll see L3 appears. And we want to make sure L4 appears besides Y list. So go second, second, and 4. All right. Then it says to press window, choose appropriate window settings. So we're going to go window. Okay. So minimum value for what was our third one, ladies and gentlemen. Minimum capacities, ladies and gentlemen, are 156, I think. Let me see. Yeah, 156. So we're just going to go 150. Okay. That's what's in the delete. Sorry, give me a second. My computer is being frustrating. Okay, so 150, that'll be our smallest one. Enter. And then our maximum capacity looks to be around 796, I think. So we'll go 800. Okay. And enter. Scale, maybe you want to go 20s for that one. Okay. Okay, now Y, which is our volume. I can't remember what our volumes are, ladies and gentlemen, so I will guess volume being 0 for our minimum, so you can enter that. And then how about we say 2,000. We'll just check 2,000 and see if that's reasonable. Okay, hit enter. We'll make a scale of about 50 for that. Okay, and now we're going to graph. Ready to graph? Press graph. And there's your data, ladies and gentlemen. Okay? All right. Great. Now we're going to move on with part 2, which is line of best fit. So line of best fit, ladies and gentlemen, notice that the data looks like it's in a linear trend, but we're not quite there yet. So now I'm going to do part 2, which is called line of best fit. You can calculate the equation by doing some statistical data from the graphing calculator. So for 8A, it says to press stat. So press stat, go over to calc, and what is it we want to do, folks? We want to do a linear regression. So see where linear regression is, number 4. So we're going to press 4. And do not press enter yet. It says we have to enter in where are we doing the linear regression, from what two data points. So we're going to do our column L3. So it's going to be second 3, comma, second or L4. Okay. And what we want to do is then say, hey, I want it in an equation, so I'm going to go comma, and then I'm going to press a different menu called the vars menu. I'm going to go over to yvars, and I'm going to hit enter and enter. What's this telling me as the computer says, hey, I want to do a linear regression between my data in L3 and L4, which are capacities and our volume, and I want you to put the equation in at Y1. All right, so let's press enter. And notice you get your linear regression there, okay? And your linear regression tells you the equation of the line. If I press graph, ladies and gentlemen, it's going to go right through there, okay? All right. And if you're having trouble looking at, you notice they've got an R and an R squared value. That's called a correlation coefficient. We're going to come back to that a little later, but I just want to make sure I could show you how to do line of best fit. All right, ladies and gentlemen, now I'm going to go back to the lesson. We've had lots of fun on the graphing calculator. We've completed those investigations. Okay, now there's nothing that lists homework here, but I do want you to take a minute or two, maybe 10, okay. Take about 10 minutes, and I want you to research graphing calculator apps, okay? Because they're going to be at your fingertip. Most of them are free. I want you to do the free ones, okay? So do graphing calculators online or for your phone. For example, if you're using an Android phone, ladies and gentlemen, the TI-83, there is a free online app for your phone, and it will appear that right on your cell phone, okay? So research that, and let's say we want to have a report on two apps. So say if you could come to class next day with 2 separate applications you've taken a look at. Tell me if they're easy. Tell them if they're fun or if they're user friendly. All right, that ends our lesson today, folks. Have a great class, have a great day, and namaste.